Alright, let's determine the x-intercepts of this rational function. If you want to find the x-intercept of a rational function, you have to pay attention to which type of rational function you're dealing with, type 1 or type 2. So if there's a type 1, there will be no constant on the end. Type 2, there is. If there's no constant on the end, then you can just set the numerator equal to 0. If there is a constant on the end, then you have to set the entire function equal to 0 and solve. So in this case, there is no constant on the end, so we should be able to just set the numerator equal to 0 and solve. So if I have x to the third power minus 9x equals 0, to solve this I would factor, and the first step of factoring is to factor out the GCF, the greatest common factor. That's going to leave behind x squared minus 9, which is the difference of two squares. So that's going to factor as x plus 3 times x minus 3. So I can finish solving this by setting each factor equal to 0. So that's going to give me x equals 0, x equals negative 3, and x equals positive 3. Alright, so at first I was expecting to have 3 x-intercepts. I'm noticing that's not one of the answer choices. And so this is a slightly more advanced problem. And so what's happening is the x's are canceling out. So if we pull out the GCF like we did in the numerator, then we had x, and then we had x squared minus 9. If we do the same thing in the denominator, then if we pull out the GCF, then we have minus 4x is the common factor. And so what's going to happen is then I'll be left with x plus 1. But the part that matters here is that these x's are going to cancel out. So there will not be an x-intercept because these are going to cancel out. So instead of being an x-intercept, there's going to be a hole right here. So that's what's going on. Sort of an unusual problem, but basically we're left with x squared minus 9 over negative 4 times x plus 1. And now if we set the numerator equal to 0, then I'll get the x plus 3, x minus 3 that we were speaking of. And setting these equal to 0, we get x equals negative 3 and x equals positive 3. So that's why these are the only x-intercepts. So if the x's cancel out, if a factor cancels out, then it's not going to count for the x-intercept.